purpose of this project is to wirelessly control a relay box's 6 electrical outputs so that we can have an automated home system. There are 3 main components. 1. Setting up the power supply for the wireless chip. 2. Writing the server software, more specifically the RESTful service. And 3. Creating the web and mobile application.
This project required a good bit of soldering. Tip tenor is the best $2 investment for this task, and make sure that soldering is easy.
Here we're testing the Adafruit Huza ESP8266 chip, which is the Wi-Fi microcontroller, and it will allow us to host our own web app. We hooked up serial monitors, which is programmed to output the debug messages, and it will currently output Wi-Fi messages and the status of the pins. For now, we wrote a web page so we can test the chip's web services, which provide 2 services. One provides the status information via JSON, which gives us information of the pins which are on or off. 2 allows us to control the status of the pins.
See the power supply, basically 110 volts through transformer to 24 volts DC. Now the 24 volts is actually a problem because it's a large jump from 24 volts down to 5 volts. You can see it has this heatsink here that gets quite hot, and we weren't able to pull too much more through this regulator here, so we're going to put a buck converter, a DC to DC converter in, and we're going to connect it here at this point. Here you can see the DC to DC converter, and I'll adjust the voltage output up to about 5 volts. And then on the right you can see on a 7 volt input, you can crank it up. You can see the output stays at 5 volts.
We built a custom backplane to connect the 8266 to the power supply. We mounted the backplane vertically on the main board so that the onboard antenna of the 8266 will not be obstructed by the metal case. We soldered a connector onto the board so the unit could be installed as a component. The software for the 8266 was compiled using the Arduino IDE and uses the Arduino Web Server library. The Web Server library allows you to map URL callback functions. Callback functions provide the web services. The base URL is mapped to serve a web page that can be used to interact, test, and web services. The web page is stored in a single C++ style string in the code. It acts like a single-page application and uses asynchronous JavaScript or AJAX requests to communicate to the web server.
The Android application was programmed using Android Studio. To get the app to connect to web services, we used the Volley library to handle the connection and also to parse the JSON. Here's a demo of our Android application. You see when it starts, the status is pending, and it pulls the web service to find the status of the relays and reflects that in the buttons. The settings screen allows you to rename the switches, and it limits the characters to 20 characters, and it does regex checking on the IP address. When the settings are saved, it'll again try to contact the service, and it'll disable the buttons until it knows the status of the relays. Here you see we've corrected the IP address, and it loads up the settings from the relays and activates the correct buttons. And that concludes our demo of our Android application.